Today's lecture examines cognitive architecture and information processing, with a focus on how human cognition shapes learning across the lifespan. In the framework of human development, cognition is not a passive storage system. It is an active, dynamic process in which attention selects information, perception organizes it, working memory manipulates it, and long-term memory preserves it for future use. These systems interact continuously, and their efficiency determines how well learners understand, retain, and apply knowledge. Working memory is the mental workspace where information is held briefly and processed. It is limited in capacity, which means instructional design must respect cognitive load. When too much information is presented at once, learners may experience overload, reducing comprehension and transfer. In contrast, long-term memory functions as a vast network of organized knowledge structures. The more connected prior knowledge becomes, the easier it is to encode new information and retrieve it later. This is why expertise changes how people learn. Experts do not simply remember more, they organize information more efficiently. Attention is the gateway to cognition. Without attention, information cannot be effectively encoded. Perception then interprets sensory input, assigning meaning based on context, prior knowledge, and expectation. Encoding refers to the process of transforming experience into memory traces, while retrieval involves accessing stored information when it is needed. Each step is vulnerable to disruption, especially when instruction is poorly sequenced or overly dense. From an instructional perspective, these principles have clear implications. Effective teaching reduces extraneous cognitive load by eliminating unnecessary complexity. It supports germane load by helping learners build meaningful schemas. Visuals, animations, and narration should work together, not compete for attention. For example, a diagram of memory systems can be paired with concise narration that highlights relationships rather than repeating the same text on screen. Similarly, animations can show how information moves from attention to working memory to long-term memory, making abstract processes observable. Information processing theory helps explain why learners differ in performance even when exposed to the same content. Differences in background knowledge, attentional control, and strategy use affect how efficiently information is processed. Therefore, instruction should be explicit, scaffolded, and responsive to learner needs. In advanced human development, cognition is best understood as both biologically constrained and educationally malleable. Ultimately, the goal of instruction is not merely delivery of content, but the cultivation of durable understanding. When educators design learning experiences aligned with cognitive architecture, they promote deeper processing, stronger retention, and more transferable knowledge.